All right, I'm just going to say a couple of things before we start. And then this beginning of this is going to be me talking a little bit. You're going to have to listen to me while I explain what all this is. Number one, we're going to cover a little bit of ground today as far as vocabulary and stuff that's new to you. So you're going to have to, kind of fight through this. My pep talk is things that are brand new don't go well right at the beginning. You're going to have to accept that when I'm teaching you a new thing, you're going to struggle a bit at the beginning. A struggle is important. If you are struggling, it means you have not given up. Do you understand what I'm saying? Because this is like getting on my soapbox here, but this is like true out in the real world, not just in like math class, okay? So it's not going to go well right at the beginning, but if you keep trying, it will start to make sense. You just have to kind of trust the process. Do you understand? Okay, because what I'm going to teach you are radians. The second thing I want to say is people try to cling on to the degrees and like hold on with both hands and won't switch over to radians. This unit we're about to do is the one unit where you're going to have both degrees and radians. After this, we are leaving degrees behind and it will be radians only, and you will never touch those degrees again, ever at all. You're going to have to let go, okay? And trust the process a little bit. Cool? We all ready? You're excited? All right. So degrees versus radians. They both represent angles, and I have that written on there too, and I have this nice little picture to illustrate it for you. Degrees represent the amount you would need to turn in order to watch your friend running around you on the track. So imagine like the track out there, except instead of an oval, it's a perfect circle. You have an imagination, you can see this. And I can't get this on the recording, but degrees would be this. You're watching your friend run around the outside and you just going like this and rotating, that represents degrees. Do you get what I'm saying? Is anyone like, you know what skateboarding is, and if you're not into skateboarding, and you're like, oh, I did a 360. Do you know what I'm saying? It means they spun around once, or I did a 180, or I did a 540. X Games. You guys know what I'm talking about, right? You're all just staring at me. Okay, so that's degrees. Radians is more what your friend is doing as they run around the circle. So the distance around the circle. 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius of the circle. So this radius, if you took that distance, it's saying this amount is equal to the radius. Here's the problem. That means 1 radian would be different for every different circle in the world. And we can't have like a measurement that isn't like standard. Do you get what I'm saying? Like, can you imagine if 1 foot was different based on everyone's foot size? You would say like, oh, something is 3 feet long. Well, how long is that? It's not standardized. Okay, so here's what we do. We divide by the radius of the circle. Essentially, you just throw it out, okay? Because otherwise, 1 radian would be different based on a little circle or a large circle. And again, this is the important thing to remember. Degrees and radians are both for angles. The trig functions, sine, cosine, tangent, and all of that, those are a ratio of the sides. We'll review real quick. Sine is what over what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is good. And then there's those other 3. Do you remember what those ones are? Cosecant is one of them. Good. Secant. You even gave them to me in the order we write them. Good job. Perfect. All right. Now our goal is to be able to convert between them. It's kind of like converting between miles and kilometers, or in chemistry, don't you convert to moles? Do you know what I'm saying? Okay, it'll be easier than that though. I like to compare to that because this is easier than that. But do you know what I'm saying when I say convert? You convert between them. We want to go between degrees and radians. 1 full circle has 360 degrees. Do you get what I'm saying? The whole way around, 360 degrees. Imagine your friend running around that circular track. If they go once around, they did the entire circumference. Does anyone, I'm just going to go fishing here and see what I get. Does anyone know the formula for the circumference of a circle? There's, oh, if you know there's a pi in it, I'm happy. It is 2 pi r. It's 2 pi times the radius. That was really close. So that's 1 circumference. And in degrees, the whole way around is 360. So this is once around for the circumference. This is once around for the degrees. And what we do is we just get rid of the radius because, again, a little circle versus a larger circle, it would be different. And we can't do that. We have to have it be standard. So here's your conversion. 360 degrees, 1 full rotation is 2 pi radians. Now you can reduce that. Dealing with smaller numbers is easier than dealing with bigger numbers. If you divide by 2, halfway around is 180 degrees. And so instead of 2 pi, good, it would just be pi. This is like your 12 inches equals 1 foot. Do you know what I'm saying? Or whatever it is for moles. I don't know what it is. I took that in 10th grade, which was a million years ago. All right. So the too long didn't read version. Hey, I listened to nothing Miss Cole just said. Here's what you need to do. To turn degrees into radians, you're going to multiply by pi over 180. To turn radians into degrees, you're going to multiply by 180 over pi. You will not be able to mess that up because the pi's won't cancel if you have it the wrong way. Also, the one that you're trying to turn it into goes on the numerator. So if you're trying to turn it into degrees, the 180 degrees goes in the numerator. If you're trying to turn it into radians, the pi goes in the numerator. Okay. This next page, we're just going to practice the heck out of doing our conversions. The pi song. Yeah. I love that when I teach this, it usually hits around Pi Day. We're not quite there yet. Like we're earlier than usual because school started earlier. Sure. I'm not gonna tell you no. All right. So for this one, you're gonna try and turn degrees into radians. You're gonna take your 30 degrees and multiply it by pi over 180. You don't get a calculator for these, so you have to be able to reduce things. But let me show you what's gonna cancel. Do you see how the degree symbols cancel? It's important for understanding what goes where, all right? Do you see how there's zeros on both these numbers? So those also cancel. Now hold on. That means you have 3 pi over 18. And how would you reduce 3/18? 1/6. So it is pi over 6 radians. 1/6 of a pi. I just do pi as 2 upward slashes and 1. It's supposed to be curly, but well, you know what? Like I said, it's always a struggle at the beginning. You're going to get used to it. You're going to write a lot of pi's. Okay. So 90 degrees, we're going to multiply it by pi over 180. And again, the point is that the degrees cancel. If you're not a person that usually writes your degree symbol, you might want to start doing that because it shows that it cancels out. And then the zeros also cancel, which is nice. You get 9 pi over 18, and you just need to reduce 9/18, 1/2. So pi over 2, 1/2 of a pi, which is a quarter of the way around the circle.
Does not actually have the pi.
Okay. All right, we're going to take our 115 degrees, multiply it by pi over 180. Now, unfortunately for this one, you can't cancel out the zeros. So this one's a little tougher. And again, you don't get a calculator. You might have to actually do a little side problem, like a little margin problem. Okay. What will both of these numbers divide by? 5. I'm going 5 is a good choice. Okay. Off to the side, I'm going to do 115 divided by 5. If you can do it in your head, congratulations for you. That's awesome. I'm going to work it out, especially because I'm doing the problem in front of everyone and I want you to see how it works. All right. 5 goes into 11. How many times? Good. 5 times 2 is 10. You subtract. You need to be able to know how to divide, especially because I taught you this with polynomials earlier this year. So if you can do it with polynomials, you can certainly do it with regular old numbers. All right. 11 minus 10 is 1. And then what? Bring down the 5. Good. And then why is it 3? 5 times 3 is 15. All right. So in the numerator, you get 15 pi. And please listen to me on this one. You're going to do 180 divided by 5 a lot. So you would do well to actually just know that one. And it is 36. We're reducing by 5. So we're doing this divided by 5 and we're doing this divided by 5 to reduce the fraction. Oh, you're right. It is. I'm so sorry. Thank you. Copy error. I'm so sorry. I just copied that over wrong. But let me say that again. You're gonna do 180 divided by 5 a lot of times. You would do well just to know that one because you're gonna do it a lot. It's 36. Did everyone kind of follow me there? Okay, 23 over 36 won't reduce, so that's actually just the answer. 23 is prime, so that's not gonna divide by anything, so you're just done with that. This next one ends with a 0, which is gonna make life a whole lot easier. We're gonna take our 240, multiply it by pi over 180. So the degrees cancel and the zeros cancel. You have 24 pi over 18, and then you just reduce the fractions. So those will both divide by what? 6, good. 24 divided by 6, 4 pi, good, 4 pi over 3, perfect. Good job. All right, and then 270, again, I like that one because it ends with a 0. It's always easier when it ends with a 0 because you can just cancel those out. You get 27 pi over 18.
Oh, wait, 9.
Good. Well, they do divide by 3. And so I'm glad you brought that up. You can divide them by 3 and then divide them by 3 again if you like dealing with smaller numbers. There's nothing wrong with that. That's not like a mistake at all. All right, but they will both divide by 9. So 27 divided by 9. So it'll be 3 pi over 2. 3 halves pi. Yeah, good. So you can put this over 1 if you want. That's what's in the numerator.
Oh, that helps.
Yeah, put it over 1. Here, you like that? I'll put them all over 1 for you.
Okay.
I got you. Whatever helps you understand it is fine with me, all right?
Wait,
Why are you laughing? If it helps, it's
wait,
good.
so you
thing.
multiply cross?
Yeah, you just multiply the numerators and multiply the denominators. It's just in that the denominator is 1, so
Oh,
bless you. All right, now we're gonna go the other way. We're gonna turn radians into degrees. So you're gonna take your pi over 4. This time you would multiply by what? 180 over pi. And look, like I was saying, you almost can't mess it up because do you see how these pi's will cancel? If you get it going the wrong way, you're going to get pi times pi, which would be pi squared. And hopefully you would go, hey, that's, not right. Okay. So this is 180 over 4. You have to do 180 divided by 4. You can do that in your head, great. Or you can go, hey, they both divide by 2. Do you want to do that? Like, could you reduce them by 2? Maybe that'll make it easier. What do you get if you divide by 2?
90.
Yeah, 90 over 2, which is 45. Good. However your brain thinks through it is fine. Like a right answer is a right answer. There's no wrong way to think about it. Yes, you will not get a decimal answer. If you did, you would leave it as a fraction. But yeah, I think I made them all whole numbers. This one, I'm going to see if you can do it without us writing anything. If it's just pi, it's 180. That's kind of like 1 foot, and you would just say it's 12 inches. You don't really have to convert it. To piggyback off of that, could you do this one without really writing anything down? Yeah, good, perfect. That's the whole way around. That's what I used to explain the thing. That's the circumference. The whole way around is 360 degrees. All right, so let's jump back to this one. 10 pi over 9, we're going to multiply by 180 over pi. So again, the pi's are going to cancel, which is the whole point. Now you could multiply 10 times 180 if you want to, but here's what I suggest doing, and watch me point to this. I would do 180 divided by 9 first because it will make the numbers smaller and you don't get a calculator. So let's just leave the 10 there for a second. Just leave it. What would be 180 divided by 9? Well, there will be a 2, but it would be 20. There you go. And then 10 times 20 is 200. So that's like a little bit, if you keep the numbers smaller, it's a little bit easier. We'll do the same thing. If you're like, hey, I didn't quite get that, we'll do the same thing with this one. Take your 16 pi over 9. You're going to multiply by 180 over pi. So your pi's cancel. And so I would just leave the 16 there for a second and do 180 divided by 9, which is 20. Now 16 times 20. Well, what's 16 times 2? 32, and then you would just put the 0 back, so 320 degrees. Sounds like we're setting our oven to like bake cookies or something. Oh, I'm so sorry. Mine are underdone. All right, so we're gonna, I know you thought you knew what an angle was, but we're gonna go ahead and make it the pre-calculus version of what an angle is. An angle is formed by rotation. So it's formed by rotating a ray about its vertex. So let's review ray just really quick. So from geometry, do you remember how you had segment and it was like stopped on both sides?
Yep.
And then a line had an arrow on both sides, but you remember how a ray had like a point on one side and then a line on the other? Like a clock hand, okay? So you rotate a ray around its vertex. So go ahead and draw a coordinate plane. I'm gonna show you what this all looks like. I'm gonna try and color code a little bit, but it doesn't show up great on here. First, we're gonna go around and state all the quadrants. You have to know all your quadrants. This is quadrant 1. This is 2. This is 3. And this is 4. Then we're gonna go around and state all of our degrees and radians. You always start right here, and I'm making this green. Maybe you can kind of bold yours. That is what's called the initial side of your angle. It won't move, it's glued right there. What does initial mean? Like, what is the word initial? First, like the starting place. Like if you've taken physics, initial velocity. Okay, that's the initial side. So if you start there, you start at 0 degrees, which is also 0 pi radians. So no degrees and no radians, you have rotated nowhere. Here's what's gonna happen, and watch, because I'll try to illustrate this. I just have like a little piece of paper. You start by rotating upwards, okay? If you get all the way up to here, how many degrees have you gone? Okay, so up at the tippy top, that's 90 degrees, which is pi over 2 radians.
Wait,
Yeah, good.
when you put 0 pi, is that 0? I'm confused.
So you actually can just put 0, and putting pi is kind of a me thing. That's a Miss Cole thing. Most people just put 0. I like to put the pi to remind myself it's radians though, like it's no pi. Okay, so we start here, we go all the way up to the top. That's 90 degrees or pi over 2 radians. If I get to here, how many degrees did we go? It's 180, which is 1 pi, 1 whole pi. Now, if we keep going, we rotate down to here at the bottom, how many degrees is that?
36. Wait, what?
You're just ahead of me. It's 270, which is 3 pi over 2 radians, pi and a half, 3/2 radians. And if you keep going and you rotate all the way back to where you started, that's 360 degrees, which is 2 pi. So if I stop my angle here, just for the sake of drawing one in, you've rotated that far, that's your angle theta, and wherever you stop is called the terminal side. So initial is where you start, that's not going to change. Terminal is just wherever you happen to end. So if I kept going, maybe my terminal side would be like over here, or down here, or like you can go the whole way around and then keep on going around and around and around and around. Did you ever wonder why this was quadrant 1 and that was 2 and that was 3 and that was 4? Did it seem backwards to you? Well, you made it far enough in your math career that you can now understand this. These are angles in standard position and we start by rotating up. That's why this is quadrant 1, and then you go into 2 and then to 3 and then to 4. Okay, positive angles rotate. I don't really leave myself enough room here. Counterclockwise, the way I was just illustrating for you. Negative angles rotate clockwise. But I feel like clockwise is almost sort of an antiquated thing because we all use digital clocks now. Here's what you need to remember. Positive, you're going to start by going up. Negative, you're going to start by going down. That's an easier way to remember it. Positive up, negative down, right? Now, when you draw these, we are not going to get out a protractor and measure them, all right? as long as you land in the correct quadrant, of which there are only 4. So if you lose your mind entirely, you have a 1 in 4 chance of guessing the right one. As long as you end up in the right quadrant, you're good. It's not going to be to scale. Okay. So for this first one, draw your coordinate plane. We're going to convert them. So if it's in degrees, we're going to change it to radians. If it's radians, we're going to change it to degrees. Let's draw it first though. Which quadrant do you think?
1.
Good. So you're going to draw that in quadrant 1. And you also have to draw which direction you rotated so that you know you didn't go backwards. So some of them are negative, right? Now let's change that to radians. You would multiply by pi over 180 to cancel the degrees. You can put the 45 over 1 if that helps you. So you get 45 pi over 180. What will those both reduce? Good. If you divide by 5,
9 over 5.
good. Well remembered. You're going to do 180 divided by 5 a lot. It's 36. You just do well to know that one. Bless you. Now that actually reduces again.
1/4.
1/4. Pi over 4. I like reducing twice sometimes. Just dealing with smaller numbers like suits me better. So anyway, we got pi over 4 for that one. All right, let's try 210. Draw your coordinate plane. Oh, we're doing good on time. All right, you want to rotate 210 degrees. Here, I'll try and illustrate it with my little piece of paper. So you start here, and you're going to go until you get to 210. Good, third quadrant. And just make sure you draw what direction you went. And then again, we're going to convert it to radians just for good measure. So the zeros are going to cancel. You get 20, oh, I drew equals twice. You get 21 pi over 18. And what will those both divide by? 3. Good. So that will be 7 pi over 6. Here's how I want you to start to think of it, because you're going to have to let the degrees go soon. Do you see how right here would be 1 whole pi? If you rotated here, that would be 6, 6. You get how 6, 6 is 1 whole pi? 7, 6 means you just went a little bit further. Yeah, the zeros canceled out. So we got 21 over 18, and then we just reduced it. So actually, I think these ones down here, I'm not going to convert them back to degrees. I want you to start to leave everything in radians. All right, this one's going to go backwards. So here I will attempt to illustrate this. Starts here, but you're going to start by rotating down. So it starts by going this way. You want to go backwards 240 degrees. So which quadrant will that leave? Good. Quadrant 2. Just show that you went backwards. That's all. When it says draw it, that's all you do. It's not to scale. We're not going to like get out a protractor and measure it or anything, right? The initial side is always right here. You don't draw that. Yeah, it just, because it just by definition is this part of the x-axis. You can draw it if you want to. All right, so times it by pi over 180. The zeros are going to cancel. The common mistake I get here is people leave out the negative. Just keep the negative in there. It's negative 24 pi over 18. I feel like we did that one already, or one similar. They'll both divide by what? 6. So it is negative 4 pi over 3. And again, just to get your brain thinking of this, if you go backwards to humor me, because I want you to understand it. If you go backwards to here, you went negative 1 pi. That's negative 3/3. So if you go 4/3, you just went a little bit beyond it. You get what I'm saying there?
Yeah.
Do you remember my pep talk at the beginning? It's going to be a struggle at the beginning, but you have to keep struggling. If you give up, then you're not struggling anymore. All right, we're going to just leave these ones in radians. I'm not going to convert them back. What quadrant do you think 3/4 would be in? I don't always say the pi because it's kind of a mouthful. So we want 3/4 of a pi. Good. 1 whole pi would be right here. If you only go 3/4, you just didn't make it to 1 whole pi. If you think about where the compass point ones are, like up, down, left, right, just which 2 are you going to be in between? Because you don't need to draw it perfect. All right, negative 1/3 of a pi. So you're going backwards. So which quadrant is what the question is?
The first. Like the fourth.
Fourth, good. I knew what you meant. It's the first one you get to, but we're going backwards in this case.
Whole pie is how
180 degrees. So 1 whole pi is halfway around, 2 pi is a full way around, which I'm actually about to bring up in this one. Do you see how that's 11 pi over 6? 12/6 would be what? 2 pi. So 12/6 would be the whole way around. Almost there, which puts you in which quadrant? Good. And that one looks kind of like a Pac-Man, so I always like that one. So you just have to figure out how far you went, which quadrant you landed in. That went well. Good job, guys. All right, go ahead and flip over. Like, here's where our vocabulary comes in. I'm gonna write this. You just write 1 pi. You're never gonna see 3/3. I just bring that up so you can compare it. Like, if it's 4/3, you just went a little past it. If it's 2/3, you didn't quite make it. All right, so coterminal means they have the same terminal side, but different amounts of rotation. So this is like you ran around the track once and your friend ran around the track 10 times, but you both ended at the same spot. Do you get what I'm saying? You ended at the same place, but they ran around a whole lot further than you. Do you get what I'm saying? Or I'm going to go this way, you go that way, I'll meet you on the other side. So you end at the same place, but you went different amounts of rotation. You following me there? Okay, so end at the same place, but different amounts of rotation. For these, if it's in degrees, you keep it in degrees. If it's in radians, you keep it in radians. First thing you want to do is draw it. Which quadrant is 150 going to be in? 2, good. It's going to look like this. Again, it's not scale, it's not perfect. Just draw it and throw an arrow in there. All right. So we're going to state a positive and a negative coterminal angle. For the positive one, and just watch me illustrate this. I'll use my little piece of paper. So, oh, hold on a second. You're way ahead of me. Hold on. So if you rotate to there, if you want a positive angle that lands at the same spot, you just add one more rotation. Do you see that? You just go once more around. What is the whole way around worth? 360. If you add that to 150, you will get one extra rotation. So what is that? 510? So that's a positive coterminal angle. If you want the negative one, that's like, hey, I'll go this way, you go that way, I'll meet you on the other side. Now, Eva shouted out the answer, but let me slow you down there. How could you get that amount? Good. 360 minus 150, but then just make your answer negative to show you went backwards. Do you get what I'm saying? You need to show that you went backwards. So it is 210, but you need to make it negative. Again, just to show that you went backwards. That impressed the heck out of me. I couldn't even ask the question and she said it. Go ahead.
How is it 5?
I just added 360 plus 150.
Like what's happening?
You're just adding them together.
This is what I do.
You're adding one extra way around. So that's like this person ran to here, and then somebody else ran once more around and landed at the same spot as them. So you end at the same spot, you just added on one more circle. So now we're going to do the same thing with radians. Let's draw it. What quadrant is 4/3 in? And again, I don't always say pi just because it's a lot. Good, third quadrant. Halfway around is 3/3, 1 whole pi. We just went a little bit further. So if you want to add on 1 whole rotation, the whole way around is 2 pi. But you need for it to be thirds. So we've done this before. Good. How did you get 6/3? 3 times 2 is 6. Good. So if you add on 1 rotation, you're just going to go once more around the circle. What would that give you? Just add them together. Yeah, 10/3. And then for the negative one, you subtract. Again, just make your answer negative to show that you went backwards. So if you subtract, that's this part. Like I usually dot it in. Like, hey, I'll meet you on the other side. Good, and it'll just be negative, so negative 2 pi over 3, just to indicate that you went in the negative direction, you went backwards. Right, so you either add 1 rotation or subtract one rotation. All right, our other vocabulary words, we did coterminal, the other one is reference angle. This is the acute angle, which what does acute mean? Less than 90. Acute angle with the x-axis. The common mistake is people draw it to the y-axis, so just try not to do that. All right. It is written like this, which is called theta prime. It has a little it's like an apostrophe, but it's not curved. Where you may have seen a prime mark before is in geometry. Do you remember when you had triangle ABC and then you translated it somewhere else and it became A prime, B prime, C prime? No, that's fine. It just looks like an apostrophe. That's all you need to know. I was going to say something else about that. It is always positive. Please try to remember that because it's sad when I have to take off half a point because somebody made theirs negative. It's by definition, it's just the definition of it that it is always positive, right? If your angle's in degrees, you're going to leave it in degrees. If it's in radians, you're going to leave it in radians. Do not change those radians. Okay, actually the radian ones are easier and I'm going to explain why. All right, what quadrant is 45 degrees?
Number 1.
First, it would look like this. Now, if you are in the first quadrant, and listen, because this is really simple and you're going to be upset if you mess it up. If you are in the first quadrant, your reference angle is your angle. So our reference angle just is 45 degrees. You didn't rotate far enough for it to be anything different. So if you're in quadrant 1, that's your answer. Like the question just is the answer. Cool? All right, what quadrant is 210 in? Third, good. You guys have got that. Knowing what quadrant you're in is like most of the battle. Now you draw a reference angle with the x-axis. So it's this part right here. Okay. Now how could we get that? Yeah, the straight line is 180 halfway around. 210 minus 180 will give you that little part, 30. Perfect. All right, then we've got negative 5 pi over 6. Now, first of all, you're going to rotate backwards. 6 is 1 whole pi. So watch, I'll show you. 6 would be 1 whole pi. That would land you here. But 5 6 means you didn't quite get there. So quadrant 3. I know what you mean by 2. You mean it's the second one that you got to, but it's still quadrant 3, okay? Now look at your reference angle is with the x-axis. The common mistake is people draw it in right here. It's this part. But here's why radians are better. Your reference angle will just have the same denominator. That's the answer. So do you see how this is 6? Your reference angle is pi over 6. Other way you can think of that, if you go 5 6, there's only 1 6 to get to 6 6. Then I know it sounds like I'm lisping there. Thank you for letting me finish that thought. Go ahead.
Because I know I'm gonna do something like this from the x-axis, but why do we not start over here to find?
So you start where you ended up, the terminal side. So it connects from the terminal side to the x-axis. So where you ended up to the x-axis. All right, I want to try one more. What quadrant? Oh, was there another question over here? I'm sorry, I just didn't see. Okay. What quadrant is 7/4 in? Here's how I would think through this. 8/4. 8/4 would be what? All the way around. Good. So you went all the way around, but not quite. So 4th. Good. It's going to look like this, like Pac-Man. Always just try to get it to one of your compass point ones. And then you either just went a little bit beyond it or didn't quite make it. It's just one side of it or the other. So your reference angle is from where you ended up to the x-axis. It's this part. It's kind of like the part Pac-Man is eating. But remember what I just told you about the denominators.
Same.
It's the same. So your reference angle, pi over 4. But here's the other way you could think of that. 7/4 plus 1/4 would be 8/4, which is the whole way around. No, it will just be 1 away. Mhm. And I'll do you one better. When we get to the unit circle, it will be pi over 3, pi over 4, or pi over 6. All of them. You almost can't mess it up.
Number on.
Correct. It just won't be there, all right? And then we have these last two little formulas. I think these are kind of cool. Your arc length, I don't know why they use S for this. That drives me crazy. It is R times theta. It's the easiest formula in the world. You just multiply those two things together and get your answer. Your sector area is 1/2 R squared theta. And here's the only thing with these, your theta has to be in radians. It will not work unless it is in radians. So if it's in degrees, you have to convert it to radians. I think these are kind of cool though. I mean, I know you're like, it's one more thing to memorize, but I think these are kind of neat. All right, draw your coordinate plane. What quadrant is 225 degrees in? Third. Perfect. All right. So what I'm going to do actually is draw a whole circle. I'm going to try to. All right. So there's our whole circle. We have our angle in the third quadrant. S is your arc length. It's the distance from where you started to where you ended up. So you're actually finding that length, which is kind of neat. I think it's cool. You can find the length of a curved thing. Isn't that cool? It's kind of cool. That's cool, guys. You can disagree, but I'm right. Isn't that neat? You can find the length of like a curved thing. So anyway, it's the radius times the angle. So it's just going to be 5 times. Now you can't have 225 because it needs to be in radians. So you would take your 225 just off to the side here and multiply by. Perfect. Now, unfortunately, you can't do the like zeros cancel out thing. So you have to divide them both by 5. This would be 36. What is 225 divided by 5? What would that be? 40, 45? So I'm just trying to move it along here because I know we're tired and we just want to finish that up. And then what would that reduce by 9? So that would be 5 pi over 4. Cool. And then if you want to put this 5 over 1, you just multiply the numerators and multiply the denominators. So what does that give you? 25 pi over 4, and it's a distance, and our distance was in inches. The most annoying part about that is converting it. This one I gave to you in radians. This one's a little bit nicer. What quadrant is 2 pi over 3 in? Good. So I'm going to draw a whole circle so you can see this. If you draw that in the second quadrant, this time we're going to find the area of this sector. That's kind of cool. That's cool. You can get that area. It's like finding an area of the amount of pizza you ate or something. But you just plug all that in. It's 1/2 R squared times theta. So the radius was 5 centimeters, theta was 2 pi over 3. We didn't have to convert it because it's already in radians. All right, so what is 5 squared? 25. I'm going to put it over 1. That helps us. And then times 2 pi over 3. So you multiply all the numerators and then you multiply all the denominators. So 50 pi over 6, which would be 25 pi over 3. Now we found an area. So what would our units be? Centimeters squared. Good. I know usually I give you feet. I just gave you centimeters to keep you on your toes.